Okay, so this video is about a review of probability. So I try to fit in all the related information of probability in these 2 pages. Um, so there are a lot of things about probability that we cannot cover. So don't expect that we'll go through everything. Maybe we'll miss something that we will mention later in the class. But I'm just trying to get you back into something that you have learned before. Um, this document I'm gonna provide you. I'm gonna upload it to Blackboard. But even though you're gonna get this document, but I still recommend you to take out a notebook to take notes of this because it's very helpful for you to write things down. Writing things down help you memorize things and help you have a better idea about what are the things that you're more familiar with and what are the things that you're less familiar with. Okay. All right. So let's take a look at the first part. So we have measures of center variation and shape when it comes to measures of data. Okay. So in terms of center, we have mean, median, and mode. Okay. Mean means average. Median means the number in the middle. Okay. If there are two numbers in the middle, then you take the average of the middle two. The last one is mode. Mode is the number that have show up for the most amount of times. You can have one mode, you can have several mode, you can also have no mode. Okay. If all of the data just show up same amount of times, then you don't have any mode. Then there is variation. So it describes how spread out is your data. We have two measures. The first one is variance. Okay, so we usually use sigma squared to talk about variance, and standard deviation is the square root of variance. So we say sigma. Okay, so I want you to remember this. Whenever I say sigma, it's standard deviation. Whenever I say sigma square, it's variance. Okay. So lastly, there's also shape. So shape described whether it's symmetric or not. Okay, so you can have a data that is symmetric or not symmetric. So here, skewness talks about how its extreme values spread out. Okay, so let's say we have income distribution that looks like this. So we can see that a lot of people's income are in the middle lower level, while there are some little rich people that can earn a lot more than the rest of us. So then we say this is skewed to the right, okay, because we have a right tail. Okay, if we see a distribution that have a long left tail, then it's called skew to the left. Okay, so that's measure of center variation and shape. All of them should be very visual and easy to understand. So now let's move on to probability. All right, so what is probability? It's the chance of something happening, right? So for example, chance of outcome A happening is called probability of A or PA. Probability has to be a number that is between 0 and 1. Okay, it can be 0, it can be 1, but it cannot be smaller than 0 or larger than 1. If we called A not happening, okay, if there's an event called A, then there's an event called opposite of A. Okay, so we call it A prime. Okay, we call it A prime. So probability A prime is 1 minus probability of A. Okay. That is not hard to understand, I hope. Then we have to define probability as a kind of its nature. So we actually have two types of probability. Okay. The first type is called discrete probability. So in the discrete probabilities case, we have limited amount of outcome. Okay, so for example, if you flip a coin, you can have head, you can have tail. I actually always wonder why a coin is called head and tail, because I never see any tail at the other side. So let's assume that your coin is not gonna land exactly on the edge. Okay, it can only land at head or tail. So then probability of head is 50%, probability of tail is 50%. Okay, so you only have two outcomes. In this case, it's discrete because you have limited amount of outcome. It can only be head or tail. Okay, and you have a probability for each of one. Another type of probability is called continuous probability. So it is a numeric value outcome defined as a range. Okay, it has to be defined as a range. So it's not like probability of X equals to A of happening. It is probability of A belongs to a range. X belongs to a range. Let's say probability of X smaller than A equals to 20%. Okay, so how do we understand this one? You can think of running a marathon. Okay, probability of my running time smaller or equal to 4 hours. Okay, I can only be smaller or equal to 4 hours or larger than 4 hours. I cannot cross the finish line exactly at 4 hours because it's just not practical, right? How do you cross the finish line at exactly 4 hours, 0 minute, 0 second, dot 00000? It's just not gonna happen. Okay, so that's not gonna happen. So that probability is 0. So you can only have a range. Okay, you can also have a range that is in the middle. You can say, I want to run 4 hours to 5 hours. Okay, so that's another probability, but you cannot have exactly 4 hour or 5 hour. Okay, so what does that mean? It means that when X equals to a specific value, in a continuous case, okay, be careful, in a continuous case, that the probability of X exactly equals to a specific value is 0. Okay, this is important because in a discrete case, this will not happen. In discrete case, for example, if you roll a die, then X equals to 1 is 1 over 6. Okay, it's not 0. But in a continuous probability, X equals to any exact value is 0. Okay, you cannot have continuous probability of an exact value. So that means you can say probability of X smaller or equal to A is 20%. You can also say probability of X smaller than A equals to 20%, and none of them are wrong. Both of them are right. Okay, so you can have probability of X smaller and equals to A that is 20%, or probability of X smaller than A that is 20%. They mean the same thing. Okay, all right. So understanding discrete and continuous are important. And in this semester, we are basically only talking about continuous. Okay, we're basically only talking about one specific continuous distribution, which is normal distribution. Okay, so we'll get there. Another thing about, okay, this is not relevant. It's probability of two events together, or two events, how to say, two events happen together, or one of the two events that happens. Okay, so we have probability A and B, which is probability A and then this and sign. Okay, this sign we call it and. it means that both A and B happened. Okay, A happened, B also happened. The second one is called probability A or B. Okay, so it can be both A and B happened, or A happened but B does not, or B happened but A does not. Okay. And there is a formula between them that probability A or B equals to probability A plus probability of B minus probability of A and B. All right, so this can be drawn into two circles. Okay, you can say this one is A, this one is B. This overlapping area is A and B, yes. How about, let me change the color. How about this large area? Okay, this color is a little bit ugly. How about this large area? Okay, so this large orange area is called A or B. Okay, it's a little bit ugly. That's fine. Okay, so the orange area equals to A circle plus B circle minus the blue overlapping area. Okay. If you don't understand, then replay this again. Okay. All right. So that's A and B and A or B. Now we move on to conditional probability. Okay. Some people find it difficult. Conditional probability is probability A conditional on B. So look at this vertical line here. We call it condition. We call it conditional on B or given B. Okay, probability A given B. What does probability A given B means? It means B already happens. What's the chance of A? Okay. So for example, what's the probability of canceling a class conditional on snowstorm is expected? Okay. So sometimes if the snowstorm is big, then probability of A conditional on B is high. Okay. It's probably 90 or 80%. Okay. I don't remember a time when a snowstorm happened and the class is not canceled. But I heard that some schools, the students really want to go to school because they say that they paid really high tuition. There's no chance that they're not going to class if there's a snow. So I don't know which school, which would not be a good news for professors, I guess. Okay. Okay, but talking about canceling class itself, it's really low. Okay, for example, now we're online canceling class. Probability of canceling class is really really small. So probability A given B means that if B already happens, what's the probability of A? Okay, it's not probability of A itself, is when there is something that already happens and both of these two events are not independent. Okay. Why do we have a condition? Because A and B have something related. Okay, if A and B doesn't have anything related, then we don't need a condition. Okay. All right, so that would be independence of events. We're gonna talk about it. Okay, so so that leads to one of the most important theorem called Bayes' theorem that says probability of A conditional on B equals to probability of A and B divided by probability of B. Okay, so here is how I remember this equation. Okay, there's A and there's a B and there's A, B everywhere, which is difficult. But usually I would like to point out B. Uh-oh, this is too large. Okay. So usually I would like to point out B. Okay. So B is the one that's at here, and B is the one that is here. Okay, so if you are saying probability of A given B, then it will be the event that both of them happened divide by the event that is given. Okay. Some of you might don't know what I'm talking about. Then you're recommended to read the slides that I provided you in the statistics books. Okay. So we will talk about Bayes' theorem later. Okay, we probably will have exercise. So now let's go to independence of events. Okay, I just talked about conditional probability. The reason why we need conditional is because these two events affect each other. Okay, we talk about canceling class and snowstorm because snowstorm would change the probability of canceling class. But so they are dependent. Okay, canceling class is dependent on snowstorm. Of course, there are other reasons that canceling class is gonna change, but the chance of canceling class, if it changed with snowstorm or without snowstorm, then they are dependent. So in one kind of case that there are independent events. So independent events happened when the chance of two events happening does not affect each other. So a good example is two alarms. Okay, one alarm failing is not gonna make another alarm failed because they work independently. Okay, so let's say probability of alarm A of failing is 10%. Okay, that's a pretty shitty alarm. And probability of B alarm to fail is also 10%. So we have to assume that they work independently. So now we ask, what is the probability that the owner will not wake up? Okay, the owner sets two alarm, both alarm independently, okay, have the failing chance of 10%. So PA to fail is 0.1. PB to fail is also 0.1, okay? Their conditional probability equals to themselves. Okay, this one is very, very important for you to understand. You should understand it instead of memorizing it, okay? How do we understand? It's probability. So the first one, it's the probability of A failing, conditional on B fail. Okay, so you can think of, does B failing affect whether A fail? No, okay. B fails, the fact that B fails is not going to affect whether the chance of A failing. So we can just take it away. Okay, if this doesn't change the probability of AF, then this one, we can just take it away. So after take it away, it equals probability AF. Okay, and reverse, it's the same. Okay, in an independent event, we have this formula because we know that the event that we say given, it's not going to change the probability of AF itself. Okay. What are we gonna do? What's the chance of not waking up? So what does not waking up means mathematically? Okay, not waking up means A failed and B failed. Okay, so it is probability AF and BF because it is independent. So we have these two probability times each other. Okay. So it equals to 0.1 times 0.1 equals to 1%. Okay. 1% is not that bad. Okay. But 10% failing alarm is still very shitty. Okay. All right, I hope that is clear. You probably still feel confused about Bayes' theorem, but I need better examples to talk about Bayes' theorem. So we'll talk about it later, okay? All right. Okay, so let's talk about probability distribution. Distribution, it's something people are very scared of at the beginning. They asked me, why do you need a distribution? I said because data don't equals to one value, data equals to several different values, so we need to have distribution. Okay. Um, so discrete probability distribution is still very easy to understand because it's easy to visualize. For example, um, uh, the distribution of probability of vaccinated. So for discrete probability distribution, you simply just list all the outcomes and list the probability of all the outcomes. Okay, so what are the outcomes? For discrete probability, we have limited outcomes, right? So we have only two outcomes, which is vaccinated, another one is not vaccinated. The last time I checked New York Times, no, it's Bloomberg. It says that the US population that are fully vaccinated is 44%. So then not vaccinated is 96%. This is a little bit simplified because I know that there are people who are fully vaccinated or vaccinated but not fully and not vaccinated. Okay, so that could be also a probability distribution. Okay, because you have limited amount of outcomes and you have probability for each outcome. Okay. But unfortunately, in this class, we focus more on continuous probability distribution. Okay. It is less easy to understand. So before I list all the continuous probability distribution, let's first talk about PDF and CDF. PDF, also called probability density function, or density of a continuous random variable. This is a function whose value at any given sample or point in a sample space, the set of positive values taken by the random variables, can be interpreted as providing a relative likelihood. Okay, that is crazy. Relative likelihood that the value of the random variable would equal that sample. Okay, this is very difficult to understand. Um, Basically, you have axis. Basically, you have an axis, and then you have another axis. You have a PDF that looks like this. Okay, so what happens for PDF is that any value, okay, any value over here, any value over here doesn't represent the probability, because remember I said that probability of x equals to any value is 0, because at any specific value you cannot exactly equals to that, okay, or the probability of u exactly equals to that value is 0. So then what does it mean? It means a relative likelihood. Okay. You probably don't need to understand too much about relative likelihood, because at the end of the day, we understand probability distribution as a range. Okay, as a range. So for example, let's go back to the example of running a marathon. Okay. You have a probability distribution. Okay. And you know that this is 4 hours. Okay. So then the area below 4 hours, okay, if you this area below 4, the size of this red area is the chance that you ran a marathon under 4 hours. Now, how about, let's change another color. How about the green side? Okay. Okay, the green side, this area, Okay. This area talks about the probability. Okay, the size of this green area talks about the probability of running a marathon over 4 hours. Okay, it doesn't matter if it's larger and equal to or just larger, because equals to 4 hour, the probability is 0. So how do we understand relative likelihood? You can simply understand it as if this thing is higher. Okay, go back to an orange line. If this line is higher, then you can imagine the blue area will be higher, right? So then the blue area will be larger. Oh, sorry. The blue area will be larger. So that is just a relatively likelihood, because it's not exactly probability, but if orange line is higher, it makes the green area larger. So that makes the probability of running over 4 hours larger. So that is just a relative likelihood. It's not exactly the probability, okay, of every point. Okay. One thing to remember, very important, that is the area under PDF has to be 0. It has to be 1, sorry. Area under a PDF is 1. Okay. Area under a PDF is 1. So then we goes to CDF. Okay, since area under PDF is 1, we can also say left side of CDF is 0, right side of CDF is 1. Okay, so what is CDF? CDF is cumulative distribution. Okay, so at every point, the value of CDF represents the area at the left side. Okay, so it says that it is called a real value random variable X, or just distribution on function X evaluated at X value, is the probability that X will take a value less than or equal to X. This is so complicated. Okay, so CDF tells you probability that variable capital X take a value less than or equal to a value lowercase x. Okay. Capital X is a variable. Whoops. Capital X is a variable. Lowercase x. Okay. Capital or uppercase letter is always variable. Lowercase letter is always a value. Okay. Some people probably start to feel confused. That's fine. Okay, it takes time. After several examples, you'll feel more comfortable about it. Okay, so CDF tells you at every point the 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 value of the probability of everything at the left side on PDF. Okay. I feel that I cannot use any words to describe CDF, so probably we'll go through some examples, then we'll have a better idea. Okay, but let's first know there's PDF and CDF, and let's first understand that PDF, under the PDF, the value is always 1. Okay. All right, so what does it mean if it's always 1? That means if this part is 0.4, 0.5, then another part is also 0.5, because these two parts have to add up to 1. Okay, all right. Whew. It's a little bit difficult to understand. Okay, so let's talk about three different continuous distributions. The first one is the easiest one, but unfortunately, we're not going to talk about it too many times in this class. So it's called uniform distribution. A uniform distribution simply says that the relative probability at every point is the same. Okay, I'm saying relative likelihood. Okay, relative likelihood, not probability. Okay, so you have an axis, and then you have a PDF. Your PDF looks like this. Oops. Okay. This is A. Okay, lowercase a. This is lowercase b. Remember, when I say lowercase, it's a value. Okay. So it means that my variable or my data is everything between number A and B. And the chance of any value between it have the same relative likelihood. How do we understand it? It's like if we slice it exactly in the middle, okay, then these two parts will equal to each other because we have the same height everywhere. Or let's say this is 0, this is 10. You have a uniform distribution. So you can say everywhere, if I just take 1, okay, this is a range, okay, this area is gonna equals to another part that the increase is equals to 1. Okay, you can say this one is A between 2 and 3, and then this one is A between 7 and 8. Okay, so because this is a uniform distribution, you can expect that these two probability is going to be the same because you are looking at the base, okay? The area, how do we calculate the area? The area is always the base times height, right? So here, because they're rectangle, even though they look a little bit ugly. So this rectangle, if you calculate it, it's always 1 times the height. So probability of A between 2 and 3 will equal to probability of A between 7 and 8. Okay. So this is probability distribution. Let me just say one more exercise to one more example. Let's say this one is 5 and this B, lowercase b, is 10. Okay, and now if I ask you to tell me what's the height, can you calculate that? So remember what we say, that if this is a PDF, then the area under a PDF has to be 1. Okay, so the area equals to base times height. How much is the base? It is 10 minus 5. The height, I don't know. So then 5 times the height is 1. So then I can calculate the height, which is 1 over 5. Okay. Let's save this to exercise. I believe everything you don't understand today can be resolved after we go through an exercise section. Okay. Okay, next we have normal distribution. All right, this is the most important thing in this class. Okay. If you don't understand normal distribution, then, or you have never heard about normal distribution, then you either spend a lot of efforts to read statistic materials or you drop my class. Okay, so first, a normal distribution looks like this. I'm gonna make it a little bit ugly, but it's gonna look like a mountain and it's symmetric. Okay, in the middle of the mountain, it is mu. We called it mean. Okay. And then how do we estimate how spread out is this mountain? Okay. Then we use standard deviation or variance. Standard deviation is sigma, variance is sigma square. So in your books or in any of your exercise, sometimes you can have n mu sigma. Sometimes you have mu sigma square. In case I just list both of them here. I think if I draw this thing larger, it's easier to see. So this is the giant axis. And then you have a giant mountain. Hopefully it's symmetric. Okay, it's not so symmetric. All right, so this is one sigma. This is another sigma. This is another sigma. So what am I doing here? So first it's symmetric. Okay. So I can write mu plus and minus 3 sigma. Why is this important? Because we usually say in a normal distribution, most of the data is within mu plus or minus 3 sigma. So you usually call a value that is outside of this range. We call them outliers. Okay, so if I change the color, so any data that comes at two tail, okay, this two tail will go forever. So if any data falls into these two tails that the value is larger than mu plus 3 sigma or smaller than mu minus 3 sigma, we call them outliers. Okay, and in a normal distribution, there is fixed probability or fixed chance that any value will fall into any of these bins. Okay, you can think of these as 8 different bins, and no matter how large is mu or sigma, there is a fixed amount or fixed shape that comes in this way. Okay. I think most people understand what I'm talking about. Okay, because normal distribution is a huge part. What happens when mu equals to 0 and sigma equals to 1? We call them standard normal distribution. Okay, so standard normal distribution is always written as n. Okay, let me change the color. Standard normal distribution is always written as capitalized n, 0, and 1. So this 1 here, you can call it standard deviation. You can also call it variance because no matter which one, it's always 1. Okay. All right. So whenever you see n, 0, 1, you know that it's a standard normal distribution. Whenever you see n, mu sigma, it's a normal distribution, but not necessarily a standard one. So we always call this one x, and we always call this one z. Okay, again, if it's capitalized, it's a variable. Okay. I think a lot of people are very familiar with standardization. That's my previous experience, that everyone seems to have a very clear idea about standardization. So what does it mean? It means that if you have just a bunch of data and you have to calculate z-score. Okay, so z, it's sometimes called z-score. I think I have a typo here. Okay, it's z-score. So once you have z-score, you can get probability related to z using ZTable. Now that everyone have access to their computer, I recommend you using Excel function. But everyone should still have a very clear understanding of ZTable. Okay, so this is the equation of how you do standardization. Okay, you have x, and you have to, if you want to transform x into z, if you want to transform a normal distribution into a standard normal, then standardization is what you do. You minus mean, and then you divide by standard deviation. Okay. So what am I talking about ZTable? So let's go back to this giant thing. Okay, if you calculated a z-score, which is here, let's say -1. Okay, this is 0, right? This is -1. then you probably want to know the probability of x or z is smaller than 1. Okay, probability of z is smaller than -1. You can say smaller or smaller and equal to, it doesn't matter. Okay, but anyway, it's this. So how do we know the area of this one? And this black area, we have something called ZTable. Okay, let me bring this down. So ZTable gives you the chance to get it. Okay, let's say -1. Okay, so how do we find -1? This is the ZTable above 0, so this is not what we need. We need -1. So let me open below 0. Okay, here it is. So this is -1.0. We need 1.00, so this is what we need. Okay, so 0.1587 is the size of this black area. Okay, 1587. Okay. Another example that I written out here is, how about z-score equals to 0.67? So then you go to ZTable. Below 0, yes. This is what you need. You find -0.6 first. -0.6, right? Yep. And then this one is -0.60. The next one is 0.61, -0.61. You need 0.67. So it is this one. Okay. All right. So it says that the probability of z smaller than -0.67 is 0.2514. Okay. Too many numbers to read. So difficult. Okay. So this is how you get how you use the ZTable. Okay. I've experienced that at the end of the semester, on the final review, students come to me and ask me how to use ZTable. So you need to know how to do this, because later on I will teach you how to use Excel to get that number. But if you don't have an idea about what's going on, then it's very confusing for you to use an Excel function without knowing what the function is really about. Okay. Oops. Okay, come back here. All right. So what does it mean? This is standard normal distribution. Here is 0 in the middle. Here is -0.67. And according to what we find on ZTable, this red area is 0.2514. Okay. What if I need another area that is at the right side? Okay. Using ZTable, I will never know the right side. Okay, let me say it again. Using the ZTable, I will never know the right side. So what do I need to do? It's not that hard because we always know that the PDF, the area under PDF has to be 1. Okay, so I simply just use 1 minus the red area to get the blue area. Okay, so then probability of z larger than -0.67, larger or larger than equals to, it doesn't matter, equals to 1 minus probability of z smaller than -0.67. Okay, so then the blue area is actually 0.7486. Okay, last but not least, this one's also very important. I'm gonna mention it for 1,000 times. We also use phi to represent this thing. Okay. let me say it again. We also use phi to represent this left area. Okay, whenever I say phi, it's left area. It's z smaller than something. Okay, so phi 1 means z smaller than 1. Phi 3.2 means z smaller than 3.2. Phi something means probability of z smaller than something. And z, I mean standard normal distribution. Okay, it's a fixed distribution and I know the value of it. And how do I find the value of it? I use ZTable. So ZTable tells me phi, which is always the size of the area at the left side. Okay, that's all for today. Okay, so next Tuesday, you guys are gonna come in and tell me if anywhere is not clear, okay? And we will practice on homework 1. Okay, I'll get you through the practice of homework 1. And don't forget, this weekend you have to submit quiz 1. And homework 1 will be due next weekend. Okay, you can go through homework 1 now because homework have unlimited attempts, but quiz only have 2 attempts. Okay. All right. That's it. I hope everyone have a good weekend. I will see everyone next Tuesday.